Hello and welcome everyone to today's webinar on transaction patterns for mission-critical microservices in Kubernetes. Thank you for joining us. My name is Tara Van Cleve and I'm a marketing event manager for the developer initiative here at Oracle. Today we're excited to show you how Oracle Transaction Manager for Microservices, or MicroTx, makes it easy to develop microservices using common app dev frameworks such as Spring Boot, Helidon, and Node.js. We'll also be recording the session, and the link to the recording will be sent to you via email in the next couple of days. If you have any questions during the webinar, we've set up a channel in our developer public Slack called Oracle Database Microservices that you can access at the QR code here or at bit.ly/odevrel_Slack. Once you're in, you'll land in the general channel, and from there you can search for the webinar channel. We will also be checking the Zoom chat and Zoom Q&A areas throughout, and we'll open up for live Q&A at the end. Today's webcast will be presented by Deepak Goyal, VP of Software Development, Brajesh Dio, Consulting Member of Technical Staff, and Todd Little, Chief Architect. So without further ado, I will hand it over to Todd.
All right, thank you, Tara. So what we're going to cover today is what are some of the challenges in using microservices to develop your applications and the data consistencies issues that those bring up. I'll talk a bit about common transaction patterns that can be used to solve these data consistency issues. I'll cover then the transaction manager for microservices or MicroTx about that product. Then Brajesh will talk about how to use the product and some examples, some code examples, and as well then talk about how this product can be used with other products, such as with Spring Boot, with WebLogic, or other environments such as blockchain or Tuxedo. And then finally, Deepak will wrap up with a little bit about what the availability and of the product is and what the roadmap looks like. So why does data consistency matter? What is the issue here? And the issue is that, as customers move away from monoliths or developing microservices, or they're developing new microservices based applications, or potentially augmenting new applications, you run into this problem where there's going to be what we call a dual write problem. And that's because each microservice tends to have its own database or its own storage mechanism. And as a result, if you have a transaction or a business application that spans more than one microservice, you now have to figure out a way to keep the data consistent between those microservices. So why is this necessary? It should be obvious, but a simple example is, you've sent some money to somebody and they're going, where's the money? You said you sent it to me, and you're going, I don't know, it's not in my account. And that's the case here where there was a dual write. There was a write to her, it should have been a write to her account and a write to his account. His account did get written to, hers did not. So this is a case where you end up with some data inconsistency through potentially an error. For lots of reasons these could happen, but the goal here is to try to solve these problems so you don't have these data inconsistencies. And the reason is because, like in this case here, financial losses. Somebody's out some money here, or somebody has some money they shouldn't have. Another example is you've fulfilled an order, but no invoice was generated, so you don't get the money for the order. You can have customer satisfaction issues, such as you get on a plane and someone's sitting in your seat, or an order was placed and never fulfilled. And finally, you could even end up with things like legal hassles, where you may have collected a signature to prove that somebody accepted something, but then you can't find that signature because it wasn't properly written at the same time the contract was updated. So these are some of the reasons. These are all fundamentally, as I say, a dual write problem. So the challenges is that you've got these transactions now that need to happen, these dual writes that need to happen consistently, and they're across multiple services. They may be, in different languages. There might be polyglot applications. They're using different frameworks. There's always concerns about, scalability when people move to microservices. How scalable are they? What might be the bottlenecks or limitations? You also have things like, different kinds of databases. So each microservice may be using its own database, and they may be of different type. One may be a SQL database, another one might be a key value database. They're all different, and trying to make sure that these are consistent is a problem. So how is this handled today? So we handle data consistency today typically by well, not just typically, but oftentimes through manual reconciliation. So this happens at at the end of the day, you find out that things don't match up, and then you have to go back and look through the logs to find out what was wrong, what was incorrect, what wasn't handled properly, which one of the writes wasn't performed correctly. Or you can build this into your application. So you can develop your own transaction management capabilities inside your application. That tends to be error prone, costly. It's a lot of work to develop that. So it also slows down your development. Or you can use existing transaction managers. The only trouble with that is that they're almost all for Java applications, or they tend to be for a single language and a single environment. And they typically only provide a single model of consistency. And we'll talk about some of those models or some of those patterns for data consistency in a second. Or they may lack things like RASP capabilities, reliability, availability, scalability, and performance. So okay, let's continue. So what are some of the common patterns for dealing with distributed transactions? So one of the simplest ones is what we call a local commit then publish. So you have a reservation service here. It takes in a request to make a reservation. It adds an entry into the table, and then it sends a message to the message broker to basically pass this request on to the next service. So it does a local commit of the reservation table and then publishes a message. And if that message can't be published, it simply retries it. So this is a very simple model. And so simple to implement. This is a very common model for event-driven applications, but some of the cons is that the participants have to be idempotent. It means they have to be able to handle receiving the same request or the same information more than once and not double process it. And it also depends upon a message broker here. So that's just another component that has to be added. Another one this is a very common one. It's called the transactional outbox. In this case, it's similar. The reservation service, it creates an entry in a reservation table, and it also creates an entry in what we call the outbox table. So this is the sort of the notification mechanism for how the reservation service is going to pass information along to the next service involved. And so those two steps of writing in the reservation table and the outbox table are done as a local transaction. And then a second local transaction is used to pick up the information from the outbox table by a message forwarder and pass that on to the message broker. And that is also done typically as a local transaction. Although the message broker may not participate in that, the message forwarding, though, is the one that starts the local transaction, pulls the entry out of the outbox table, calls the message broker, and if it succeeds in publishing the message, then maybe it'll either update the outbox table or delete the entry in the outbox table. The problem, this is very easy to implement. It only uses local transactions, but again, it requires idempotent participants, and it depends upon the separate message forwarding daemon, which is another component to monitor, manage, and keep up and available. So another one is event sourcing. So an event sourcing, this is typically used for event-driven applications. You generate an event, and each event is placed in a log. And that log contains enough state information about who else needs to be contacted and whether that's been successful or not. So the reservation service makes an entry into the event log, commits those records with the two events, one to say I've got to notify the flight service, and one that says I have to notify the hotel service. Then the dispatcher then picks up that event from the event log and tries to dispatch it to the appropriate service. If it succeeds, then it marks that it has been updated. If not, then it marks it as needing to be retried. Later comes back and retries this. This is one advantage here is that the event log gives you a complete history, so you can do the temporal queries about what happened with these transactions. And it gives you a complete history of what went on with the application. The difficulty again is that requires idempotent participants. It depends upon the dispatcher daemon, and it also requires application logic for compensation. So if eventually you reserve the flight, but the hotel can't be reserved, you have to unreserve that flight that was already made. So that requires application-specific compensation logic. Sagas, this is becoming one of the more popular models right now, especially with the things like Eclipse microprofile, long-running actions. That's a form of sagas. So in this case here, the reservation service, it gets a request, and it starts a saga by notifying a transaction coordinator or the saga coordinator that a saga has begun. It then contacts the flight service to reserve a flight. The flight service sees that it's part of a saga and enlists in the saga with the transaction coordinator. And then again, the reservation service does the same thing with the hotel service. Once the reservation service has all the reservations it needs, it then calls the transaction coordinator to complete the saga. And at that point, this transaction coordinator calls the complete saga operations on both the flight service and the hotel service. And that's where then they can complete the reservation or do whatever else is necessary. Should there be a failure, what will happen instead is that the reservation service will ask the transaction coordinator to compensate the saga, and then the transaction coordinator calls the compensate saga operation on the flight service and hotel service. So this works very well. Again, it has the advantage that there's no locking required in this. It's very flexible. You can do, and any participant can decide to complete the saga. This works quite well, but it does again require idempotent participants. You need a transaction coordinator or a saga coordinator, and again, you require application provided compensation logic. So when you get the compensate request, you have to figure out what's necessary to be able to undo your portion of the transaction. It also lacks isolation. And that's a critical piece because it means that other services or other transactions may make use of stale data, and that can lead to incorrect results or unexpected results. XA is a very well-known transaction protocol. It's similar to the Saga in that you start a transaction by calling the transaction coordinator. You then make calls to each of the participants. They enlist in the transaction, and then the initiator, in this case the reservation service, says to commit the transaction. Transaction coordinator then calls each of the participants to commit. Or at least in this case here, we'll explain a little bit more about that about MicroTx. First, ask each of the services to prepare and then to commit. And should there be a failure, instead of asking them to prepare and commit, the reservation service says to roll back the transaction. The coordinator then is responsible for notifying each of the services to roll back their partial transaction. The one advantage of this is it's extremely simple for the developer. There's no application-specific compensation required, and it provides full isolation, so you get full ACID properties of a transaction. There are some potential performance issues due to locking, and as well, you may have some additional latency because there's additional interactions that have to take place. And like many of the other sort of models that require a coordinator, you have to have a transaction coordinator involved. And finally, the last model is what we call try, confirm, cancel. So in try, confirm, cancel, again, the reservation service makes a request to reserve a flight and to reserve a room. It's very, very HTTP specific. So you do a post to get that, you get back a URI from those services that represent the reservation. And then once the reservation service has collected enough reservations, the reservations that it needs, it can then ask the transaction coordinator to confirm all those transactions. And so that's done with a put request because put requests need to be are idempotent by definition. So this allows them basically to be able to either collect all the flights, or should there be a failure, then what will happen is the reservation service will ask the transaction coordinator to delete the transaction, which in turn then the coordinator will call each of the participating services to tell them to delete their reservation. So it's very simple, it's fast, there's fewer round trips. There is some additional complexity though, in that the participants need to track those reservations. They need to keep the state around so they can know what to do when you get the delete operation or the put operation. And as I say, typically this is useful when you're using reservations or putting something in escrow. And it may or may not depend upon a coordinator. The coordinator could be part of the reservation service itself in some environments. So if we look at these patterns, we can look at them and rate them on a, how consistent the data is that they provide, what level of data consistency they provide, and the ease of implementation. And what we look at for what we call the choreography patterns. So these are the patterns that don't require a transaction coordinator or a Saga coordinator. So event sourcing, transactional outbox, Sagas and LRAs may or may not need a coordinator. So they can be either choreography or they can be orchestration. So orchestration includes then like try, confirm, cancel, and XA. And as you can see, XA provides the strongest data consistency and as well the easiest to implement. This is where MicroTx comes into play and what we're focusing on. So in MicroTx, we're going to be focusing on Sagas, try, confirm, cancel, and XA. Speaking of XA, I want to do a little bit of myth busting here about XA, since it gets a lot of flack in the microservices world. And some of the myths that I would say are that people claim that microservices don't need distributed transactions. Well, then I ask, how do you solve the dual write problem without them? And the transactions may not need to be in these forms. It can be in other forms as well. But there still is this notion of a set of work that has to be done atomically. Sagas are good enough. Well, that's another one where if I put some money in an account and before I commit that, the local transaction commits. So the money is there. But the Saga hasn't completed yet. Somebody else may come along and withdraw that money and complete their Saga. And then when I try to compensate the Saga, the money's not there to be able to give back. So you may end up where compensation can't even be done with something like a Saga. Transaction coordinators, there's a single point of failure. Well, that's really a really bad transaction coordinator if that's the case. Certainly things like MicroTx are highly available and scalable, and it's not a single point of failure by any means. XA is too complex. I love this one because you're correct in that XA is relatively complex for the provider of the transaction service, but for using it, it's simple. All that happens is the initiator brackets the transaction. So it starts it or ends it, or starts it or commits it or rolls it back. Whereas Sagas, you have to create this idempotent compensating logic, and that can be non-trivial. And then the last one here is actually these are performance issues. And that can be the case because of the locking involved, but I think in well-designed applications, this can be avoided. And we know we've done some testing of these with MicroTx and exceeded 1,000 XA transactions per second. And there aren't a lot of applications that need more than that. So a little bit about the transaction manager for microservices. So it consists of, it's another microservice itself along with a set of libraries. So it allows you to develop applications in multiple languages. So you can develop in Java, in Python, soon to be Python, currently Java and JavaScript. These can be deployed in Kubernetes or deployed elsewhere in another service mesh environment, but it's definitely aimed at a microservices environment. And you can use different transactions or different databases or resource managers. So if we see in the middle here, we've got the coordinator itself, we've got the participating applications, you've got the data store for the transaction log that the coordinator needs to maintain. Typically then, if this is in like Kubernetes, you're going to have an ingress gateway. You have some application that acts as the transaction initiator, and it makes use then of our libraries then to be able to interact with the coordinator and be able to interact with the participants. Benefits of using it, let's say reduce application complexity, improve productivity. We think that we know it's based upon industry standards, things like XA and long-running actions for microprofile are well-defined standards for transaction processing. Gives you faster time to market. You can focus on their business logic and not on the transaction or compensating logic. And as I say, you can use existing frameworks and development assets. So it consists of two major components. The first component is the transaction coordinator. This is what handles the stepping through the phases of a transaction. And as well, then we have the transaction coordinator library. So the MicroTx library. And this is contained in each of the components and provides a set of capabilities to allow you to call the transaction coordinator as well as to be able to interact with other microservices. The transaction coordinator itself is just another microservice. So it can be, it's deployed in your same environment. So it's just runs in a container, runs in a pod. You can have replicas of it. So it scales up, scales down, just another microservice in effect. And we use REST-based communication. So as long as your applications are using REST, it's very easy then to integrate in with MicroTx. Something that we do in MicroTx, which is a little bit different, if you saw that picture before when we talked about the XA approach, what happens normally in XA is that the initiator asks the transaction coordinator to begin the transaction, calls some application code, the application code calls some database work, and then the initiator says to commit or roll back. The transaction manager at that point directly talks to the resource manager. Well, if you wanted to create a polyglot transaction manager, now you need to have implementations of all those languages, and you need a connection to the resource manager itself. So that means you need the credentials, you need a network connection to the resource manager and the like. That's extremely difficult to do. So what we've done instead is in MicroTx is we proxy the access to the resource manager for the transaction manager. So the transaction manager, instead of talking directly to the resource manager, it calls to our library, and inside the application code, there are callbacks that are provided by our library, and they proxy the request to prepare, commit, and roll back through the proxy to the resource manager. So this makes the transaction manager completely resource manager agnostic. Something else we do is we also provide interceptors. So these interceptors handle requests, REST requests. So they intercept the outgoing REST request to add transaction headers. So the participant that's being called can examine our interceptors there, examine those headers, and then enlist the participant in the transaction. So by using these filters, which are provided and registered automatically by the library, we can propagate the transaction context from one microservice to another microservice. So this eliminates the need for the application to be worried, even in many cases, about the transaction itself.
All right, so let's start this section by taking a look at some use cases that demonstrate the use of the 3 transaction patterns supported by MicroTx. This is the first one. This is a use case for a trip booking application that uses the LRA pattern, and there are 3 microservices for booking a trip, which includes a flight and a hotel booking. The trip service is the leading service where the LRA is started, and it calls flight and hotel services for booking a trip in an atomic manner. All services communicate with each other via REST endpoints. The flight and hotel services join the LRA when the LRA client in both these services make a REST call to the MicroTx coordinator to join the LRA. And when both the flight and hotel bookings are successful, the trip service completes the LRA by making a REST call to the MicroTx coordinator. The coordinator then calls the completion REST APIs on the flight and hotel services. Otherwise, in case of any failure, the trip service cancels the LRA, and the coordinator then calls the compensate REST APIs on the flight and hotel services. So that concludes a trip booking. Let's have a look at another use case here, which is an event booking use case that uses the try, confirm, cancel pattern. In this use case, a user sends an event booking request to the booking service, which makes a theater booking and a restaurant booking in an atomic manner. The booking service sends requests to the theater service and the restaurant service to obtain reservations in the form of URIs. The user can then confirm or cancel the event booking on the booking service, which sends a confirm or cancel requests to the MicroTx coordinator, along with the theater and restaurant reservation URIs. The MicroTx coordinator then calls confirm so the MicroTx coordinator then calls the confirm or cancel on the reservation URIs in the theater service and the restaurant service. The difference in the TCP pattern from the LRA pattern is that there is no enlisting of participants with the coordinator. Now let's have a look at another use case that uses XA. So this use case is for a teller application that creates an XA transaction coordinated by the MicroTx transaction coordinator. In this application, the teller service can transfer amounts from one department to another. by creating an XA transaction. And there are three microservices. Again, the teller microservice, the department 1 and the department 2 microservices. Both department 1 and department 2 use separate Oracle databases. And a user makes a REST call to the teller microservice. The teller service provides a transfer operation that can perform withdraw and deposit operations on accounts in as an atomic operation. The teller service begins an XA transaction by making a call to the MicroTx coordinator, and then the teller service then calls the withdraw service in department 1 and deposit on the department 2. The MicroTx library in the participant microservices provide the functionality to enlist in the XA transaction. If both the withdraw and the deposit calls succeed, the teller service then calls commit on the MicroTx transaction coordinator to commit the transaction. The coordinator then calls back to all the participants via the included MicroTx library to prepare all the participants. Once all the participants are prepared, the transaction coordinator then calls back to all the participants to commit their transaction branches. Finally, the transaction coordinator returns success or failure to the initiator's request to commit the transaction. So this is how the XA can be implemented using MicroTx. Now, these are some of the steps for creating a Java application that uses XA. In the case of XA, there are two types of participants, an initiator and a participant microservice. And both the XA initiator and the participant microservices must use the MicroTx library. The XA initiator microservice is the one that creates or initiates an XA transaction. And it also creates the transaction boundaries by using TrmUser transaction instance, which is part of the MicroTx library. The XA participant microservice needs to initialize the MicroTx library by providing an XA compliant data source, usually a database, to the MicroTx library. The MicroTx library creates an XA connection with the past data source and injects a connection into the application code. And the application code then must use the MicroTx injected connection to the data source for performing any DML queries. Let's have a look at some source code for an XA initiator Java application. As you can see here, the TrmUser transaction class needs to be imported here, and then we create an instance of the TrmUser transaction that creates a new transaction, and then you define the transaction boundaries by calling transaction begin that begins the transaction, and then you run your business logic within the begin and commit calls. In between, if there is a need, if there is any failure, then you can roll back the transaction by calling rollback on the transaction instance. So this is about the initiator. Now, in the case of a participant application, the first step is to initialize the MicroTx library by passing an XA compliant data source. So this is what you can see here. We have a data source, and then we call the init.xa data source and pass the data source into that. And then the trmconfig, which is part of the MicroTx library, also provides methods to initialize logging. The second thing that a participant application must do is use the MicroTx injected connection for executing any DML queries with the data source. So this is what is highlighted here. There is a TRM SQL connection annotation. So using that, the connection is injected, and then you can see that the connection is being used to run the query. These are some of the steps that a developer needs to perform to quickly get started with application development using MicroTx. The first one is to download the MicroTx distribution package from this URL. And then you can also run the MicroTx coordinator locally using Docker on your laptop. So you can just run this command as shown here. So this pulls the container image from the container registry and runs it inside your Docker container on your laptop. And then you can view and run the different sample applications that are present in the distribution package. You can start application development by modifying an existing sample application, or you can create a new application by using the examples that I showed up here in the slides. So in this section, I'm going to talk about the interoperability of MicroTx with existing systems and applications, and also the different deployment options for MicroTx. Yeah, the MicroTx transaction coordinator is a microservice, and it can be deployed in any containerized system that is used to deploy microservices, and can also be deployed within overlay networks like a service mesh having a request router or a load balancer. The MicroTx coordinator can be deployed in Kubernetes and Docker Swarm environments, and it can support native integration with the Kubernetes ecosystem. The MicroTx coordinator can be deployed in Kubernetes with or without a service mesh like Istio. So this is what you see on the right side. So most of these tools and the open source softwares that they work with MicroTx. Let's have a look at the type of resource managers that are supported with MicroTx for XA. For Java applications that use XA, any XA compliant resource manager should work. The resource manager should have a JDBC driver that implements the XA data source and the XA resource interfaces. We have tested with Oracle database, PostgreSQL, and MySQL. And it should also work with the other resource managers such as Microsoft SQL Server and IBM DB2. And MicroTx supports two-phase commit with the Oracle blockchain platform as well. Likewise, for Node.js applications that use XA, an XA compliant database driver is required, and we have tested with the Oracle database. MicroTx also supports a logging last resource optimization, which is called LLR optimization, by which one non-XA compliant resource manager can be used in one of the participants of an XA transaction. Databases such as MongoDB can be used in such participant microservice. And then when using LRA or TCC protocols, any resource managers can be used in the participant microservices. MicroTx can interoperate with existing enterprise applications by having a transaction initiator microservice call existing applications and services, and have them as participants in a transaction coordinated by MicroTx. In some cases, the existing applications need to integrate the MicroTx library for the applications to work with the MicroTx coordinator. On the right side, you can see that Node.js or a JavaScript application using an Oracle database or a chain code application in the Oracle blockchain platform can become participants in a transaction that is coordinated by the MicroTx coordinator. Similarly, Tuxedo applications written in C, C++, or COBOL can also become participants in an XA transaction. The required support has been implemented inside Tuxedo. Likewise, PL/SQL applications that run in an ORDS Apex environments are also supported for being participants in an XA transaction. MicroTx provides a PL/SQL library for these applications to work with MicroTx. And then RESTful applications that are deployed in WebLogic and use the MicroTx library can also participate in XA transactions coordinated by MicroTx. So this is how an Apex ORDS applications work as XA participants. You can see that there is an XA initiator that initiates the XA transaction. We have the MicroTx coordinator. There is another participant. And then on the right side, this is the ORDS, XA ORDS application that becomes a second participant in an XA transaction. And then the MicroTx provides a PL/SQL library that has the required functions and stored procedures for coordination with the MicroTx coordinator. And there are very minimal steps required to use MicroTx when existing with the existing Apex or ORDS applications. Similarly, for WebLogic applications to work as XA participant, all you need is a JAX-RS-based RESTful application in WebLogic that can become a participant in exit transaction. And the application can use either database or the WebLogic JMS as resource managers. Existing EJB applications that use database or JMS as resource managers, they can also become participant in exit transaction with MicroTx. The requirement is that they must be fronted by a JAX-RS application, and there are no code changes required in existing applications to be able to work with MicroTx. This is the overall high-level architecture for MicroTx when deployed in Kubernetes cluster with Istio or Envoy service mesh. As you can see here, you have the MicroTx coordinator that is running inside the cluster. And then there can be other microservices like a Node.js based microservice based on the Express framework, or Java Helidon microservices, Spring Boot microservices, even Tuxedo service, or a PLSQL application that is running in an ORDF or Apex environment. And then MicroTx also provides a console that has a dashboard where you can get details of the transaction, and then you can also view the MicroTx configuration. It also provides some administrator functions to administer the transactions inside the console. And then MicroTx already supports some of these open source tools for monitoring, log management, and distributed tracing. And then these are the resource managers that are supported with MicroTx, the Oracle database, including RAC database, and then the Oracle blockchain platform. And then any other XA compliant resource managers can also be supported with MicroTx. So this is the overall architecture. I will now pass it on to Deepak to talk about the MicroTx availability and the roadmap.
So, Brijesh, if we go to the next slide, I'll talk about what we have been doing with MicroTx so far. As you would see in the next slide, we have this product became available about a year back, not quite a year. September 22, we announced this, and we released support for all these XA, LRA, and TCC features, Java and Node.js. These are programming languages that we support. Few optimizations for XA transaction like LLI, LRC, nested transaction, and so on. And as Brijesh and Todd talked about this MicroTx, the product is designed to work with Kubernetes. It can be deployed in other environments also, but it was from scratch designed to work in a Kubernetes environment. So any Kubernetes environment can be deployed. It can be deployed across Kubernetes clusters as well. It's secure out of the box, and it supports various resource managers. Then we made several enhancements, so it can run with service mesh or without service mesh. There is session affinity for better performance and transaction recovery. And the latest release has support for the Spring Boot. This is a new service that Oracle has announced recently, and it's going to be available sometime at CloudWorld this year. And then one major change actually in this release 22.3.2 was interoperability with WebLogic server. So now you can have your existing WebLogic server applications like written in EJBs or whatever it is, and then you can have other microservices running outside of WebLogic server and still participate in the same XA transaction. Now you can also do the multiple RMs, support for Python for TCC protocol is there, and of course the maintenance. If we go to the next slide, I want to talk about free versus enterprise versions. So free product is there for you to today, for you to use today, and evaluate what the functionality is and if it meets your use case and or not, and all those things. So MicroTx Free is basically targeted for application development for developers like yourself to evaluate, develop, and test application. It's 100% free. You don't have to buy the license for this particular product. You can just download from Oracle's site and start using it. There is, of course, sample application user documentation that is included. The limitation there is that it supports 4,800 transactions per hour. And there is community support. So you can you can ask questions from the community if you face any issue and so on. We are going to release an enterprise edition also of this product. This is targeted for production deployment. It would include all the features from MicroTx free and enterprise level features. So if you're developing mission critical application, you need high availability, resiliency, scalability, etc. So all those things would be included in this enterprise edition. License can be obtained using perpetual or monthly subscription pricing. Both would be available. It would have unlimited transaction throughput, no limitation on that. And you can get regular support from Oracle in addition to the community support. So just like for any other product that you open a service request, you can do the same thing with MicroTx as well, with Enterprise Edition. We also may plan to make it available in OCI Marketplace so that it's easy to deploy in OCI. You can use it anywhere where the Kubernetes cluster can be deployed, whether it's OCI or in your own data center, etc. But with this marketplace, it would become much easier. So if we go to the next slide, I just want to see, I want to tell you what we are focusing on as we go along. So ease of development. You can use MicroTx with your Spring Boot-based application as of today, but we want to make it further easier to use Spring Boot and MicroTx together. Right? So there we are going to provide some Spring Boot specific clients which are using the Spring REST API rather than JXRS that we use today. Also the Spring 3.x support. Spring Boot is going to end of life, Spring 2.x towards the end of the year. So that we are working on, then the new samples and live labs. And high availability and resiliency feature, so persistent storage of transaction state. For enterprise application, you want to make sure that even if there is a crash of MicroTx or your machine or environment, your transaction state is available and it can be restored. Transactions can be recovered. So for that, we are going to allow you to store the transaction state either in Oracle database or in etcd in addition to memory. MicroTx is highly available. As Todd and Vijay said, MicroTx is basically a microservice by itself. And you can have multiple copies of microservices running or this MicroTx coordinator running. So for high availability and scalability as well. And then this transaction management when using Oracle RAC, enterprise developers and enterprise applications use RAC on the back end. So you should be able to use MicroTx with RAC as well. And then various optimizations to improve the performance of the application, state cache. You don't have to always go to the database to store the transaction state. It can be cached before and written later. Promotable transaction, you don't have to start the exit transaction all the times. You can start with the local transaction and we'll promote it to the global transaction only if another resource manager is involved in that particular transaction. Log-free reservation, this is something where you do not have to write the compensating code if you are using Saga. This is a new feature in Oracle Database 23C, and we are going to use that feature and provide interaction with MicroTx. So it would reduce the developer burden, of course, significantly. That compensating logic developer does not have to write the compensating logic. And then XID optimization, this is another optimization for exit transactions, where if we recognize that all the transaction branches are pointing to the same resource, we don't have to do a two-phase commit. Rather, we can just do the one-phase commit in this case. And then enhanced usability. So towards that, there is going to be a console that can be used to monitor what is going on with the MicroTx and all the transactions, its state, and you can take actions like rolling back the transaction or committing the transaction and so on. I mentioned MicroTx in Marketplace and then Grafana dashboard, right? So because this MicroTx is already a Kubernetes product, we want to make sure that the Kubernetes ecosystem is very well integrated with the product. So we are going to provide out of the box dashboard and tools to diagnose the problems and trace the issues, etc., that might occur. And last but not the least, I just want to summarize here like what you have heard so far and why you should use the top 10 reasons in that style, right? We believe that this is a very unique solution. There is nothing else that that is available in the industry that can solve this problem. And why we say this is unique, because we are talking about here distinct microservices that are running in different containers in Kubernetes, and now we can coordinate transaction across these. Other solution that might be available in the outside, they just look at one monolith, even though it might be running in Kubernetes, but it's still a monolith because that's what they are coordinating transaction with. This monolith may use multiple resource manager, but if you go across different processes running in Kubernetes, that solution is not there. We are unique in that way. And then we provide a choice of transaction protocols. You can use XA, you can use Sagas, LRAs, or you can use TCC. So whatever works for your application, you can do that. It's designed for Kubernetes. Programming languages, we support Java, Node.js, as well as Python for TCC. And we are planning to support Python for XA and Sagas as well. And then better user experience. Of course, if you have this transaction consistency across your application, then your end users see the results in real time rather than eventual consistency, right? If you are using XA. DevOps issues are fewer because there is a consistency. You don't have to do the manual reconciliation. Developer burden is reduced, especially if you're using XA. You don't have to write this compensating logic and all those things. It's automatically done for you. It's identity providers. So with the cloud, and the token, any token solution that you can integrate with. And we support actually a number of resource managers with MicroTx. Of course, like Oracle database integration is optimized, but we support other resource managers also, like PostgreSQL, MySQL Server, as Brijesh was mentioning, even MongoDB actually and MongoDB can be include in an XA transaction as a non-XA resource using the LRC and LLR transaction optimization. And last but not least, here again, it can interoperate. You can write the microservices, and these microservices can interoperate with your existing applications. It could be a Tuxedo application written in C, C++, or could be WebLogic, which is written in Java, or could be even database Apex application that is written in PL SQL. So all those applications can interoperate with MicroTx-based microservices as such.
I dropped some resources throughout in the chat. So we have the slide deck there, which will also be linked in the recording. And we also have a live lab that you can try out. So there's a workshop link there. And then if you wanted more information, how to get started with MicroTx, the link that's on the slide now. Thank you all again so much for joining us, and we hope to see you again next time.